بسم الله الرحمن الرحيم الحمد لله والصلاة والسلام على رسول الله. This is Math 113, the first major examination, Term 241. Let us have a look to the exam and solve it together. The first question is about the definition of the definite integral. Use the definition of the integral, the limit of Riemann sums, to evaluate this integral. So we have a formula. The definition of the integral says that the integral of f of x dx from a to b is equal to limit n goes to infinity summation I from 1 to n f of x I times delta x. This is the definition of the definite integral as a limit of Riemann sum. So this is the Riemann sum, and this is the limit. And delta x here is b minus a, that's the interval, over n. And xi, by definition, is a, the first number, the left side of the interval, plus I times delta x, which we found here. So in this example, or in this question, a is 0, b is 3. So delta x would be 3 minus 0 over n. And xi would be, all what you need to do to use the definition is to find delta x, then xi, then f of xi, then multiply f of xi times delta x, then find the summation, then the limit. And pay attention that you need to compare this integral to this integral. So by comparison, a is 0, b is 3, and f of x is x squared minus 2. So you need to understand this and to use this information. So what is xi? It is a, where a is 0, so I am not going to write it because 0 plus anything doesn't count, plus I times delta x. So you just multiply delta x by I, so I'm going to write it 3i over n. If you multiply this by I, it is 3i over n. Good. Now I need f of xi. So what would be f of xi? Well, this is f of x. So I need to replace x by xi. So it would be xi squared minus 2. And what is xi? It's 3i over n. So when you square it, it would be 9 I squared over n squared minus 2. So this is f of xi. And now let me find the summation of f of xi multiplied by delta x, where I is from 1 to n. Notice that delta x is 3 over n, and f of xi is this one. So you can do whatever you like here. I'm going to multiply them. So I have f of xi, which is 9 I squared over n squared minus 2. This is f of xi times delta x. So let me multiply them. I have two terms here and one term, so I have to distribute. So 3 times 9, it's 27 I squared. This is multiplying the numerators, and the denominators, n squared times n would be n to the power 3. You add the powers. Good. And then minus 2 times 3 over n, it would be minus 6 over n. So this is the summation. Now we have some properties for the summation. I can take the constants out of the summation, and I can distribute the summation when I have plus or minus. So 27 over n cubed, this is constant because it has no I. I here is the variable. So take 27 over n cubed outside, and then I'll have summation I squared from 1 to n. And 6 over n is constant, so I can take it out, 6 over n, and I'll have summation 1 from 1 to n. Well, I have properties now, some formulas about the summations. I know, for example, that summation 1 from 1 to n is n because I'm adding 1 n times. And also I know that summation I square from 1 to n is equal to n times n plus 1 times 2n plus 1 over 6. We have this formula. We know it and you can go back to the lectures. So I'm going to use these formulas. So summation would be equal to 27 over n cubed. This is the constant outside. Now what is summation I squared? It is n times n plus 1 times 2n plus 1 over 6 and minus 6 over n times summation 1, which is n. So let me do some cancellation. I have n and n cube here, so they cancel. I'll have n squared down in the denominator. 27 over 6 I can divide by 3, so I'll have 9 over 2. This is 27 over 6. And n with n, so I'll have n plus 1 times 2n plus 1 over n squared and minus 6. So this is the summation. Now I need to find the limit when n goes to infinity to get the integral. So now this is the final step. So I'm going to write that integral from 0 to 3 x squared minus 2 dx using the definition is equal to the limit when n goes to infinity of this one minus the limit. The limit can be distributed, okay, whenever you have minus or plus. Now how to evaluate the limit when n goes to infinity? We take the highest power in the numerator. So if you multiply these two, the highest power is 2n squared, and the highest power below is n squared. And limit 6 when n goes to infinity is 6. N squared cancels with n squared, 2 cancels with 2, and the limit would be 9. And here I have 6. 9 minus 6 is 3. That's the answer, and you can check that your answer is correct by evaluating this integral using the calculator. You can evaluate this integral using the calculator. The graph of f is shown. Evaluate the integral from 3 to 10 f of x. Well, from 3 to 10, from here to here. So from 3 to 10, you know that the definite integral gives the area below the curve, okay? This area is below the x-axis, so it would be negative, and this area would be positive. This area, you can find it in one rule, area of trapezoid. But if you like, you can make it two areas. So the area of the rectangle plus the area of the triangle plus the area of half a circle. But these two areas would be negative. So the integral from 3 to 10 f of x dx would be equal to the area of the rectangle. Well, the area of the rectangle is the width times the height. The width is 2, the height is negative 3 because it's down, so negative 6. This is the area of the rectangle. Now the area of the triangle base times height, which is again negative 3 times half. So it is half times 3 times negative 3. And half, not half, even the quarter of a circle, because this is half of a circle, but this is a quarter of a circle. Well, what is the area of the circle? The area of the circle is pi r squared, and this is pi positive because it's above the x-axis. Pi r squared. What is r? The radius. The radius is the distance from the center to the circumference or the outer curve. So it's 2. So 2 square 4. So 4 pi, this is the area of the circle. I need quarter, so I'll divide by 4. So the final answer would be, this is negative 9 over 2, negative 6. So it's negative 21 over 2 plus 4 pi over 4. Cancel 4 with 4, and it is pi. Find the derivative of this function. Well, we have the formula that d by dx of integral from a to x f of t, fundamental theorem of calculus. In derivative cancels the integral, and I'll have f of x. You replace this t by x here, by the variable x, and you get f of x. Well, here a is 5, but it is not in this form, so I need to interchange a and b here. Also, when I interchange, this one would be a function, not x, so I can use the more general integral, the more general formula when I have a here and g of x here, function of x, and here f of t dt. So the answer in this case, the derivative cancels the integral, and t is replaced by g of x. So I'll have f of g of x, and since this is a function, you need to multiply by the derivative of g. So I start by, let me f of x, which is this one. I'm going to write it negative when you interchange the limits of the integral. Write 5 here and then x squared there. You need to put a minus sign. E to the power 5t plus 1 over t dt. So this is f of x. And now let me find the derivative. So f prime of x. So f prime of x would be dy dx of the integral, and I have a negative sign. And the derivative of this integral, I'll use this formula. It would be f of g of x. So I replace t here, I replace t by the function there. So I'll have e to the power 5 times t, which is ln x squared, plus 1 over t, which is ln x squared. So this is, all of this is f of g of x. I replace t by g of x. I replace t here by ln x squared. Then I multiply by the derivative of g, the function I replaced with. What is the derivative of ln x squared? Well, the derivative is 1 over x squared times the derivative of x squared, which is 2x. If you want to simplify this, I can say that f prime of x, you can leave it like this if you like. If you want to simplify, keep the minus outside. Now here, I need to take 5 up. This is ln, so I can take 5 up. It would be x squared to the power 5. It would be x to the power 10, and e cancels with ln. So I'll have x to the power 10. Plus here, you can take 2 outside if you like, and write it 2 ln x. And x cancels with x, and you have 2 over x. You can write 2 over x here or leave it here. That's the answer. Evaluate the following integrals. Well, I have 3ex. I know the integral of ex, and there is a constant. I take it outside. Secant tan, also there is a formula for the integral of secant tan, and integral works with the negative. I can distribute the integral, so I can say that this is equal to 3 times integral from 0 to pi over 4 of ex dx minus 4 times integral from 0 to pi over 4 secant x tan x dx. So there is a 3, and the integral of ex is ex, and from 0 to pi over 4 minus 4. Integral of secant tan is secant, because the derivative of secant is secant tan from 0 to pi over 4. So this is 3 times e to the power pi over 4 minus e to the power 0, which is 1, minus 4, secant pi over 4, and secant pi over 4 is square root of 2. You can just use the calculator. You have to be in the radian mode if you don't know how to find this in the radian mode, not in the degree mode, shift mode, and choose radian. And now ask for secant. Secant is 1 over cosine. So ask of 1 over cosine and write pi over 4. You have pi below. So the answer is square root of 2. Okay, so you can do that by the calculator. And minus secant 0. You can also use the calculator. 1 over cosine 0. It would be 1. So that's the answer. You can leave it like this. If you want to simplify it, you can write it 3e to the power pi over 4 minus 3 minus 4 square root of 2 and plus 4. So there is a minus 3 and plus 4. So it would be plus 1. And this would be the answer of the integral. Now, the second integral, I have product x squared multiplied by this one. Integral does not distribute when I cannot distribute the integral if there is a product. So I have to do something. This is raised to the power 2 over 3. So there is no formula like this problem directly. So I need to do something. I have integral by substitution. Maybe to use integral by substitution, this one 4 minus x cubed, I need the derivative of 4 minus x cubed to be outside if I take it u. Well, the derivative of 4 is 0. The derivative of x cubed is 3x squared. I have x squared here. So I need to multiply by negative 3. That's no problem. So I'm going to write it, integral. I'll multiply by negative 3. And it is not up to me. I have to divide also by negative 3. So I didn't do anything now, multiplying and dividing by negative 3. So this is 1. Does not change the integral. Times 4 minus x squared to the power 2 over 3 dx. And now the integral is ready to take u equal to 4 minus x squared, what is inside parentheses. And du would be, the derivative would be, derivative of 4 is 0. So it would be negative, this is x cubed, sorry. This is x cubed. So it would be negative 3x squared. That's the derivative, dx. So now this integral can be changed to negative 1 over 3 is there. And negative 3x squared multiplied by dx is just du, and usually we write it to the right. And 4 minus x cubed is u, and I have the power. So I changed the integral from integral in x to an integral in u. It's much easier because I have a formula to find the integral of u to power n. The integral is negative 1 over 3 is a constant, u to the power 2 over 3 plus 1. So you add 1. 2 over 3 plus 1 would be 5 over 3. 3 over 3 plus 2 over 3 over 5 over 3. You have to divide by 5 over 3 or multiply by 3 over 5 plus c. So finally, 3 with 3 cancels and I have negative 1 over 5. U to the power 5 over 3. I can go back now to x by replacing y by u by 4 minus x cubed. So I can write it 4 minus x cubed. This is the u to the power 5 over 3 plus c. So this would be the final answer. Also here I have division, quotient, and I cannot distribute the integral if I have quotient. So there is no formula to evaluate this direct formula. So I need to do something. I have integral by substitution. Well, I need a function to call it, something to call it u, and the derivative should be outside. I have ln x to the power 2. So this is in fact similar to this because whenever you have something to some power, you need to think of this as u. So I need to think of ln x as u. So if I take ln x as u, then du would be the derivative of ln x, which is 1 over x dx. Well, I have 1 over x dx. So this integral would be integral of ln x, which is u square, and 1 over x dx is just du. Good. And now 1 and e are values of x, but I changed x to u, so I need to change these values to u values. So if x is 1, then u would be ln 1, that's 0. And if x is e, then u would be ln e, and ln e is 1. So the integral now is from 0 to 1. And this is a very easy integral. It's u cubed over 3. I can take 1 over 3 out, and u cubed from 0 to 1. So 1 cube minus 0 cube, so it's 1. So the answer is 1 over 3. So that's the answer. Find the area of the region enclosed by the given curves. Let me draw the area first. I have x0, I have x1. So the graph would be, if this is 1 and this is 0, between x0 and x1. And y equals x squared plus 2. This is a parabola. This is y. This is x. This is a parabola. It is y equals x squared. So I know that the graph of y equals x squared, but taken 2 units up. So I know that the graph goes like this. But I can replace x by 0 and x by 1 and find out what would happen. So if x is 0, I'll have 2, which is this point. And if x is 1, y would be 1 plus 2, which is 3. So I have this point. So this would be, it will go up, but this is the graph between 0 and 1 of this function. It's a curve, it's not a straight line. And y equals negative x squared plus 1. I know the graph of y equals x squared. It's this parabola. Negative x squared will make it open. The parabola will open downwards like this. And plus 1 will take it 1 unit up. So the graph would be like this. I know the graph. Okay, the graph would be like this. But also, if you don't know the graph, you can replace x by 0 here, see what happens. So it's 1. So this point, it will go down like this. And if x is 1, what would happen? Negative 1 plus 1 would be 0. So it will go to this point. So the graph is also parabola like this. Okay. And it continues down. But this is the graph. And it's also a curve. This is the graph. So this is the region. This is my region. And this region, I need to find the area of this region. Well, you need to think now which rectangle would cover this region. You can choose a vertical rectangle like this, or you can choose a horizontal rectangle like this. Now, which rectangle here is better? The rectangle that's better, you need to move the rectangle. This horizontal rectangle, you need to move it up and down through the area. Now, if always there is a curve to the right of the other curve, then this rectangle would be good. But in this case, it's not, because if this rectangle goes up, then this line would be to the right of this curve. And here between 1 and 2, this line is to the right of this line, and below I'll have this line is to the right of this curve. So to use horizontal rectangle here, you need to divide this region into 3 regions. That's too much for me. While if I use just a vertical rectangle, move this vertical rectangle, move it anywhere, bring it here, always this curve, which is this one, y equals x squared plus 2, is above the other curve, which is negative x squared plus 1. So now the formula says that the area in this case, because you are taking a, uh, vertical rectangle, if you take a vertical rectangle, what would be the width? It is dx, it's part of x axis, so we call it dx. So this integral would be with respect to x. And this x runs from where to where? This is x. From where to where? from 0 to 1. So x runs from 0 to 1. And you need the height of the rectangle. You multiply the width by the height. The height of the rectangle will be the above curve minus the below curve. So the above curve is x squared plus 2 minus negative x squared plus 1. So this will give you the area of the rectangle. So let us now solve the integral. It's from 0 to 1. Let us simplify. Let us expand. So I have x squared plus 2 minus times minus plus x squared minus 1 dx. Now I can add x squared with x squared. So I'll have 2x squared and plus 2 minus 1. This is plus 1 dx. And now 2 is a constant, and integral of x squared is x cubed over 3. You can take 3 over 3 out, and you need to find x cubed from 0 to 1 plus, maybe this is not clear. Okay. 1, the integral of 1 is x, and it is from 0 to 1. So here 1 minus 0 is 1, so I have 2 over 3. And here 1 minus 0 is 1. So the answer is 2 over 3 minus 1. This is a plus 1, sorry. This is a plus 1. This is a plus. So I found my mistake. This is a plus here. I wrote it minus, so the answer is 5 over 3. Sketch the region enclosed by the given curve. Y equals the square root of 8, square root of x, y equals 2, and x equals 0. Well, x equals 0 is this line, the y-axis, and y equals 2 is this line, and y equals the square root of x. Square root of x is like this. This is square root of x, and this is x equals to 0. So this is the region. So we sketched the region. Find the volume of the solid obtained by rotating the bounded region about the x-axis. We rotate this region about the x-axis, we get a solid. And the question, what is the volume of this solid? Again, you need to think first whether you will take a horizontal rectangle or a vertical rectangle. For a vertical rectangle, this line would be always above this curve. So that's good. A vertical rectangle is good. For horizontal rectangle, if I take a horizontal rectangle, also always this curve would be to the right of the y-axis. So also horizontal rectangle here is also good. So in fact, I can solve this method or this problem in two ways. Either by using a vertical rectangle or by using a horizontal rectangle. So let me start by using vertical rectangle. If I rotate this vertical rectangle about the x-axis, I'm going to get a washer. And you should know that also for method of washer, disk, and washer, the rectangle is always perpendicular to the axis of rotation. So if you are going to use a vertical rectangle, then we will use the washer formula. And the washer formula says that the volume is, now, what is the width of the rectangle? See, the width is part of x-axis, so it's dx, so I need dx here. So x will run from where to where? From 0 to this number. I'm not sure whether this number is 5 or something else. So how to find out this number? Well, this point is the intersection between the curve and the line. And this line is y equals to 2, and the curve is y equals to square root of x. So square root of x has to equal 2. This is the intersection point. Then if you square both sides, then x is 4, and y is 2. So this point 4 and 2. So x is 4, in fact. So from 0 to 4, then pi, the outer radius square minus the inner radius square. This is the formula of the washer. Where is the outer radius? The outer radius, you start moving from the axis of rotation up because the graph is up. You pass by two curves. The first curve you pass with is the inner, and the second curve would be the outer. So the outer radius would be the distance from the x-axis, the axis of rotation, to the second curve, which is the line. The line y equals to 2. So this distance from the x-axis to the line y equals to 2 is fixed. It's always 2. So this would be integral from 0 to 4. I can take pi out if you like. So the outer radius is 2 squared, so it's 4 minus the inner radius. Now the inner radius, if you go from the axis of rotation to the first curve, this distance changes. Okay, this distance changes according to the curve. So it's in fact the y of the curve square root of x, because the distance, the vertical distance is y. So y is equal to square root of x. So it's in fact square root of x. So the inner radius is square root of x squared, so it would be x dx. So this will give you the answer. Of course, this is pi. The integral of 4 is 4x, and x from 1 to 4, minus integral of x is x squared over 2 from 1 to 4. So the answer would be pi times 4 minus 1 is 3. It's from 0 to 4, sorry. See, you have to write clearly so you don't make mistakes because of your handwriting. So from 0 to 4, okay, 4 minus 0 is 4 times 4, that's 16. And here 4 square is 64 minus 0, 64. 64 over 2, that's 32. So it is 16, uh, sorry, 4 square is 16. Sorry, 4 square is 16 minus 0, so 16 over 2, that's 8, not 32. Again, if it is 32, the answer would be here minus, and the volume is never minus. Okay, so I know that I do a mistake. I did a mistake. I reviewed my work, so it's 8. So the answer is 8 pi. This seems good. This answer is accepted. The volume is 8 pi. Or if you want, you can use a horizontal rectangle. So allow me to erase this. And if I use a horizontal rectangle, then this rectangle would be parallel to the x-axis, the axis of rotation. So I'm not going, this is not the method of disk and washer, it is the method of cylindrical shells, because when I rotate this rectangle about the axis of rotation, I'll get a cylinder, okay? A cylinder like this, a cylinder. So this is the method of cylindrical shells. So what is the formula for cylindrical shells? Well, what is the width of the rectangle? The width of the rectangle, the horizontal rectangle, is part of y. So it's dy. So the volume would be, the formula is 2 pi times the radius, which is y, times the height, which is f of y, dy, and y from c to d. Well, y here runs from where? From 0 to 2, so it's from 0 to 2. Y is the radius, because this is the radius of the rectangle. It's the distance y. If you rotate the rectangle, this is the radius of the cylinder. And the height of the cylinder will be the height of the cylinder. It would be from here to here. And this is the x. This is x value of this curve, This is the curve y equals square root of x. So you need to find x, you need to solve it for x. So y equals square root of x. To solve it for x, you square both sides, and x would be y squared. So I'll have the integral would be from 0 to 2. You can take 2 pi outside if you like. Y times f of y, which is y squared. So I'll have y cubed dy, and this would be 2 pi. And integral of y cubed is y to the power 4 over 4 from 0 to 2. And pi, this is pi over 2 now, 2 cancels with 4, and 2 to the power 4 is 16. So 16 times pi over 2 is 8 pi, which is the same answer. So whether you solve it by this method or this method, your answer is correct. Use the method of cylindrical shells. Well, here he didn't determine the method, so both are correct. You can solve by cylindrical shells the two questions. Why not? Use the method of cylindrical shells to find the volume generated by rotating the region bounded by these curves. Let us draw the region. I have y equals square root of x and y equals x cube. This is y equals x cube, and this is y equals square root of x. And you can find the intersection point between the two curves. Um, it's clear that it is at 1, because when x is 1, y is 1 in both curves. But if you want, you can write x cube equals to square root of x. You are solving the two equations together. Y equals to y. If you raise it to the power 2, x to the power 6 would be equal to x. If you bring x to the other side and take it as a common factor, so you will have either x is 0 or x to the power 5 minus 1 equals to 0. So x to the power 5 equals 1. And if you take the fifth root, x would be equal to 1. Of course, this equation has another 4 roots, but we need the real roots, so 0 and 1. So this point is in fact 1 and 1, because if you replace x by 1, you will get y equals 1. So we need to rotate this area about what? This region, about what? About the y-axis. This is the y-axis, this is the rotation. Now, which rectangle should I choose? Well, if I choose a vertical rectangle, this curve would be above this curve always. So it's good, I don't mind. If you choose a horizontal rectangle, this curve would be to the right of this curve always. So also here, both method works. But he said use cylindrical shells. So to use cylindrical shells, the rectangle has to be parallel to the y-axis, the axis of rotation. So I must choose here uh, a vertical rectangle. So when you rotate the vertical rectangle, you will get a cylinder. And the width of the rectangle here is dx because it's part of the x-axis. So the integral would be integral 2 pi. The radius here is x, not y, because we need dx. F of x, not f of y, dx. And x is from 0 to 1. So this will give you the integral 2 pi x. And what is the height? The height is the above curve minus the below curve. So it's a square root of x minus x cubed, because square root is above x cubed dx. And you can find the answer. So you can take 2 pi outside, and this is product multiplication. So I can't find the integral. I have to expand. X times square root of x will be x to the power 1 plus half, which is 3 over 2. You need to add the powers, minus x times x cube, 1 plus 3, you add the powers is 4. And now this is equal to 2 pi from 0 to 1. Let me find the integral. Can find the integral now. So the integral of x to the power 3 over 2 is x to the power 3 over 2 plus 1. That's 5 over 2, 3 over 2, plus 2 over 2, over 5 over 2, or multiplied by 2 over 5. And 5 over 2, this one should be from 0 to 1, minus, of course, 2 pi will be multiplied by both of them. Okay, 2 pi is outside, minus integral of x to the power 4 is x to the power 5 over 5 from 0 to 1, and the answer would be 2 pi. And I'll have here 1 to the power 5 over 2 minus 0, that's 1. So I have 2 over 5 minus, this is also 1 minus 0 is 1. 1 to the power 5 is 1, so a negative 1 over 5. And this would be 1 over 5 times pi, so it is 2 pi over 5. That's the answer. Well, you cannot use here the other method because he said you have to use the method of cylindrical shells. But exercise for you, do it at home. What about use the method of disk, use disk and washer method, okay? If you use disk and washer method, then you will use a horizontal rectangle. And to use a horizontal rectangle, the width of the rectangle would be dy. So the integral would be, the formula would be integral from y is again from 0 to 1, out by times outer radius square minus inner radius square. So the outer radius would be the distance from the y-axis to this one, to the outer curve, which is x cubed, okay? So it would be this distance. And this distance is the x distance of this curve. So x cubed equals to y. You need to solve it for x. So it would be, in fact, cube root of x minus, but cube root of x what? Squared. Because the outer radius should be squared. Minus the inner radius is from here to here. So it's the x coordinate of this curve. So if you solve this curve for x, x is y squared. So this is not cube root of x, this is a cube root of y, sorry. Because everything here in terms of y. And now x would be y squared. And you can use the calculator if you like, or do it by yourself and check that the answer is the same answer here. Just to be able to use the two methods whenever it's possible, you know. The last question, find the average value of this function. Well, the formula of f average is 1 over b minus a, where this is ab, the interval, integral from a to b fx dx. So 1 over 3 minus 1, that's 2. Integral from 1 to 3, the function given in the question, 2x squared plus 5x over x dx. I have quotient here. I cannot distribute the integral over quotient, so I need to think of something. I know that a plus b over c equals a over c plus b over c. So I just can write this as a half integral from 1 to 3, 2x squared over x plus 5x over x dx. And then it would be a half times integral. Now, x squared cancels with x, it would be x. And x cancels with x, it would be 5. So the integral, I have half outside. And the integral of 2x is 2x squared over 2. And integral of 5 is 5x from 1 to 3. This is 1. So I have 1 over 2 outside. And 3 squared is 9 plus 5 times 3, that's 15, minus replaced by 1, I have 1 plus 5. So 9 plus 15 is 24 minus 6, that's 18. 18 over 2 is just 9. That's the answer, and this was the last question. I hope you benefited from this video. Wish you good luck.